The universe is a grandiose web woven of galaxies, dark matter, and gravity. Among this cosmic web, two of the most amazing structures stand out. Superclusters of galaxies, giant megacities of space. And ghost galaxies, invisible and mysterious objects lurking in the shadows. Today we'll explore how these phenomena are related, what they tell us about the nature of the universe, and why scientists believe they are the key to unlocking the biggest mysteries of the cosmos. What are superclusters of galaxies? Let's start with the largest objects in the universe, superclusters. These are giant structures that combine thousands of galaxies and span millions of light years. If you think of the universe as a huge city, galaxies are houses, galaxy clusters are neighborhoods, and superscopes are entire metropolises. Superclusters are made up of galaxy clusters separated by wastelands, regions virtually devoid of matter. One of the largest superclusters is the Great Wall of Hercules North Corona, which is over 10 billion light-years long. Ghost galaxies, the invisible neighbors of superscopes. But what's going on inside these superscopes? Among thousands of galaxies, scientists have discovered mysterious objects that emit almost no light. These are ghost galaxies. Why are they called ghosts? Minimal stars. Unlike normal galaxies, they contain almost no luminous stars, so they look like blurry patches. Dark matter. The basis of such galaxies is dark matter, which holds their structures together. Examples: Virgo Heta-1, a ghost galaxy in the Virgo cluster, made almost entirely of gas and dark matter. Dragonfly 44, a galaxy containing 99.9% dark matter. How do superclusters and ghost galaxies form? Processes for the formation of superscopes. After the Big Bang, gravity began to bring clouds of gas and dark matter together, creating stars and galaxies. These galaxies clustered into clusters, which then formed superclusters. Formation of ghost galaxies. In the early universe, some regions failed to reach the density necessary for star formation. These failed galaxies were left filled only with dark matter and gas. In some cases, gravitational interactions with other galaxies stripped them of stars and gas, turning them into ghosts. The role of superscopes and ghost galaxies in cosmology. Superscopings are the giants of the cosmic web. Superscopes are the skeleton of the universe. They show how matter is distributed on the largest scales. Studying them helps us understand the influence of dark energy on the expansion of the universe. Ghost galaxies are the key to dark matter. These invisible objects allow us to study the distribution of dark matter, which makes up about 27% of the total mass of the universe. Without ghost galaxies, we would not be able to observe the effects of dark matter on gravity. Study methods. Studying superscopes. Telescopes such as Hubble and James Webb help build three-dimensional maps of the distribution of galaxies. Maps of the cosmic microwave background show how mass was distributed in the early universe. Searching for ghost galaxies. Gravitational lenses help detect their mass through the bending of light. Radio telescopes detect the emission of neutral hydrogen that may be present in such galaxies. Examples of superscopes. Laniakea, our local supercluster that includes thousands of galaxies, including the Milky Way. The Shapley Superscope, one of the most massive structures in the known universe. Examples of ghost galaxies: HEO 450-958, a starless galaxy associated with a bright quasar. Dragonfly 44 contains an extremely small number of stars with a huge mass. Mysteries and the future of exploration. Despite progress, many questions remain. How have superclusters persisted in an expanding universe? Why are ghost galaxies so diverse in their characteristics? How are these objects related to the evolution of the entire cosmic web? Future projects, such as new radio telescopes and computer simulations, will help us unravel these mysteries. Galaxy superclusters and ghost galaxies are not just amazing structures. They help us understand the universe, its evolution, and the nature of dark matter. By studying them, we unlock the mysteries of the cosmos itself. Galaxy superclusters and ghost galaxies are not just scientific facts, they force us to rethink humanity's place in the universe. These structures remind us how vast and mysterious the cosmos is. We are only beginning to understand how dark matter, gravity, and the evolution of galaxies are interconnected. Each new step in the study of these phenomena opens up more questions than answers, but that's the beauty of science. It's hard to imagine that dark energy and matter, which we can't see or feel, form the basis of the entire universe. Ghost galaxies like Dragonfly 44 demonstrate how diverse the worlds hidden from our eyes can be. And superclusters like Laniakea show how everything in the universe is connected together, forming a complex but amazingly beautiful cosmic network. Perhaps the answers to these mysteries will change not only our understanding of the cosmos, but also of ourselves. After all, the more we study the universe, the clearer it becomes how grandiose it is and how much there is still to discover. How many more mysterious structures do you think we'll find in the future? What are you more interested in, giant superclusters or mysterious ghost galaxies? If you enjoyed the video, give it a like, subscribe to the channel, and share your thoughts in the comments. Together, we're exploring the universe. Dark galaxies are mysterious objects that may exist in space, but remain invisible to our eyes and instruments. They contain almost no stars and emit almost no light. Their structure is held together by dark matter, a mysterious substance that makes up about 27% of the mass of the universe, but remains invisible to us. Their structure is held together by dark matter, a mysterious substance that makes up about 27% of the mass of the universe, but remains invisible to us. Imagine, in the silent darkness of the cosmos, there are galaxies filled with gas and dust, but lacking the brightness of stars. They're like ghosts of the universe, leaving behind only faint traces. Scientists call them dark galaxies, and their existence remains one of the greatest mysteries of modern science. Why does the universe need dark galaxies? There are hypotheses that dark galaxies may be a kind of building blocks for larger galaxies. They may have served as sources of gas and dark matter for objects like our Milky Way. In ancient times, dark galaxies may have merged with ordinary galaxies, adding mass and changing their structure. This means that our understanding of galaxy evolution may be incomplete without studying these invisible structures. Interestingly, scientists speculate dark galaxies existed long before bright galaxies appeared. In that era, the cosmos was filled with objects that did not emit light, and stars had not yet begun to form. What was the role of these galaxies in cosmic history? Perhaps they kick-started the development of the visible universe. Candidates for the title of dark galaxies. In recent decades, astronomers have identified several objects that could be dark galaxies. HEO for 50958. This quasar, found at the edge of a large gas cloud, has long been a mystery. The Hubble telescope did not detect any galaxy associated with this object, prompting speculation that it wasn't a dark galaxy. However, further research failed to confirm this hypothesis. Virgo Heta 1. This object, found in the constellation Virgo, was also long considered a candidate for being a dark galaxy. However, more recent observations have shown it to be an intergalactic gas cloud with no significant presence of dark matter. These examples show how difficult it is to identify dark galaxies. Their nature is still a matter of debate and research. The nature and composition of dark galaxies. Scientists hypothesize that dark galaxies are made up of the following components. Dark matter. This is the main element that provides gravitational binding. Gas hydrogen. Its presence is confirmed using radio telescopes. Dust. Small particles that may be remnants of collapsed stars or other objects. Some hypotheses suggest that there may be stars in dark galaxies, but they are so few that they emit almost no light. The mass of gas in such galaxies can reach billions of solar masses, making them significant objects to study. How are dark galaxies detected? Dark galaxies cannot be seen through optical telescopes because they do not emit visible light. Instead, scientists use radio telescopes like Arecibo to examine the 21 cm line of neutral hydrogen. This method can detect even the faintest traces of gas. The Arecibo Galaxy Environment Survey (AGES) has become one of the largest projects to search for dark galaxies. Radio telescopes can detect regions rich in gas but devoid of stars, giving scientists a chance to detect such objects. Alternative theories and the significance of dark galaxies. Many scientists believe that dark galaxies were the precursors of today's large galaxies. For example, Martin Hanel has suggested that our Milky Way formed after merging with several dark galaxies that added mass and volume to it. If this hypothesis is correct, dark galaxies played an important role in the formation of the visible universe. They may be the key to understanding the structure of galaxies, their interactions, and evolution. Key questions for science. What is the exact nature of dark galaxies? How many of them exist in the universe? What role do they play in the creation of stellar galaxies? These questions continue to stir the minds of astronomers. Perhaps future technologies will allow us to look beyond the boundaries of the visible and confirm or deny the existence of these mysterious objects. Dark galaxies remain one of the most intriguing mysteries of modern astronomy. Like ghosts hidden in the darkness, they play an important but still incomprehensible role in the evolution of the cosmos. If we can unlock their secrets, we may change our understanding of the entire universe. What do you think? Could dark galaxies be the real builders of our Milky Way? Share your opinion in the comments. Don't forget to subscribe to our channel so you don't miss even more interesting facts and mysteries of the universe. Click on the bell to be notified of new videos. Thank you for watching us.
The mystery of the event horizon and hypotheses about the hidden side. Black holes are some of the most mysterious objects in the universe that continue to captivate the minds of scientists and enthusiasts around the world. They are peculiar mystery machines, where the usual laws of physics seem to cease to apply. What happens inside a black hole? What hides behind the event horizon, where even light cannot escape? Let's delve into this mysterious topic and consider not only what we already know, but also hypotheses that can shed light on this cosmic phenomenon. What is a black hole? Basics. A black hole occurs when a star of enormous mass exhausts its fuel and collapses under the influence of its own gravity. This process produces an object with such a strong gravitational field that even light, the fastest thing in the universe, cannot leave it. Event horizon. The event horizon is the boundary around a black hole beyond which no information, not even light, can escape. It is a kind of point of no return. Anything that crosses this boundary becomes inaccessible to the outside world. But what happens inside this mysterious area? This is where the most interesting part of the research begins, because the physics we use to explain the world around us begins to break down. Traveling beyond the event horizon. Imagine you are on a spaceship approaching a black hole. The closer you get, the stronger the gravitational field becomes. At a certain distance, effects begin to appear that confirm Albert Einstein's theory of relativity. Time slows down and space becomes distorted. The effect of tidal forces. The black hole's gravity is so strong that it stretches objects falling into its field. This effect is called spaghettification. An astronaut approaching the event horizon will be stretched into a long thin line because of the difference in gravitational force between his feet and his head. However, to an outside observer, the process looks quite different. They see the astronaut slowing down and freezing in time right at the event horizon. So what do you see? As you pass through the event horizon, you will not notice the abrupt transition. Visually, there will be total darkness in front of you. Light from objects inside the black hole cannot reach your eyes, and everything outside becomes inaccessible due to the curvature of spacetime. The singularity, the heart of the black hole. At the center of a black hole is the singularity, the point where the density of matter becomes infinite and spacetime is curved to its limit. In this area, the physics we know, including the general theory of relativity, ceases to work. Scientists believe that the singularity holds the keys to understanding quantum gravity, a theory that would unify quantum mechanics and relativity. Hypotheses about the singularity. Quantum foam. According to some theories, the singularity may not be a point of infinite density, but a region where quantum effects create a frothy structure. Einstein-Rosen bridge wormhole. Some scientists speculate that black holes may be entrances to wormholes, tunnels that connect different points in spacetime. But even if this is true, traveling through such tunnels is probably impossible because of the instability. Holographic projection. Another hypothesis states that information absorbed by a black hole is stored on its surface and can be recovered. What could be on the other side? The main question on the minds of scientists and space enthusiasts is, what lies beyond the singularity? Is it possible that a new world or even another universe lurks there? White holes. Some theories suggest that black holes may be connected to white holes, hypothetical objects that eject matter and energy but do not absorb it. If such a connection exists, it could mean that black holes are a kind of bridge between different parts of the universe or even different universes. Multiverse. The multiverse hypothesis states that our universe is just one of many. If this is true, then black holes could be portals to other universes. Of course, this idea remains highly speculative, but it inspires new research. Hypothetical scenarios. What if the Earth were to fall into a black hole? If the Earth were to end up in a black hole, events would unfold dramatically. As it approached the event horizon, the planet would be stretched by tidal forces and the atmosphere would vaporize due to extreme radiation. To an outside observer, the Earth would have frozen in time at the event horizon, gradually disappearing from view. However, for the Earth itself and its inhabitants, time would continue to pass until they reach the singularity, where their fate remains a mystery. Could black holes be portals? A popular idea from science fiction is black holes as portals to other dimensions. In reality, traveling through a black hole is highly unlikely due to intense tidal forces. However, theoretical models, such as wormholes, allow for the possibility of a tunnel effect between different parts of spacetime. But the stability of such tunnels remains questionable. Life near a black hole. Do conditions exist for life near a black hole? Some scenarios suggest that complex chemical reactions could occur in accretion disks, regions around black holes where matter is heated to extreme temperatures. However, high radiation and gravitational forces make the existence of life near black holes unlikely. Current research. Today, black holes are at the center of attention in the scientific community. The Event Horizon Telescope EHT project continues to explore event horizons, providing images of black hole shadows with incredible precision. The James Webb Space Telescope Observatory opens up new possibilities for analyzing the neighborhoods of black holes, including their interactions with the surrounding matter. Link to quantum mechanics. Black holes provide a unique laboratory for the study of quantum mechanics and gravity. The problem of information loss in black holes remains one of the most intriguing mysteries. Current research suggests that information can be stored on the event horizon in the form of quantum fluctuations, which links black holes to the theory of a holographic universe. Technological breakthroughs. The study of black holes is spurring advances in technology. Modern telescopes, such as the James Webb, are equipped with sensors that can detect minute changes in spacetime. These technologies have applications not only in astronomy, but also in other fields such as medicine and communications. Why it matters. The study of black holes is of great importance to science. Here are a few reasons why. Understanding the nature of gravity, black holes provide a unique opportunity to study extreme gravitational fields that cannot be replicated on Earth. Testing theories. They help test the general theory of relativity and look for ways to combine it with quantum mechanics. Searching for new knowledge. Black holes may hide clues to understanding the fundamental laws of the universe. Technological breakthroughs. The study of black holes requires the development of new technologies that can then be applied to other fields. Current advances in the study of black holes. First image of a black hole. In 2019, a team of scientists from the Event Horizon Telescope EHT project presented the world with the first image of the shadow of a black hole at the center of the galaxy M87. This was a historic event that confirmed the existence of the event horizon and opened a new way to study these objects. Gravitational waves. In 2015, scientists first recorded gravitational waves, ripples in spacetime caused by the merger of two black holes. This discovery confirmed the predictions of relativity theory and provided new tools for studying space. Information theory and black holes. One of the most intriguing questions is the information loss paradox. If information about material absorbed by a black hole disappears forever, this contradicts the laws of quantum mechanics. Current research suggests that information can persist on the event horizon in the form of a hologram, which links black holes to the theory of a holographic universe. Future research. Research on black holes is just beginning. With advances in technology, such as more powerful telescopes and computer modeling, we can expect new discoveries that will change our understanding of the universe. Next-generation missions. Space observatories, such as the James Webb Space Telescope, will be able to study black holes with greater precision. Quantum gravity. Theories that combine quantum mechanics and gravity could help explain what happens inside a black hole. Artificial intelligence. Using AI to analyze huge amounts of data will speed up the process of discovering new phenomena. Black holes are mysterious and amazing objects that continue to challenge our understanding of the universe. What happens inside a black hole? The answer to this question remains elusive, but each new discovery brings us closer to figuring it out. Perhaps studying black holes will not only unlock the secrets of the cosmos, but also change our perception of reality. Keep exploring, keep asking questions, and keep wondering. After all, the universe is full of mysteries, just waiting to be revealed.